पता करो जितना जल्दी पता करोगे, ठीक है. सो आवर चैप्टर इज केमिकल बॉन्डिंग, and if you see now we'll get the advantage of the way we were studying in detail. See, this chapter starts with element, compounds and mixture, which I'm not going to touch again because we have dealt element, compound and mixture in detail, much more in detail than what it is covered here. Also, it's just half a paragraph. Since it is about bonding, so we will talk about bonding. Let's understand chemical bonding properly, okay? So let's start with chemical bonding. So first I will tell you whatever the flow process is there in my mind. So we want to discuss in this chapter about something called a chemical bond. A chemical bond, and this chemical bond can be formed amongst elements, okay? And after the bond is formed, after the chemical bond is formed among elements, that is, you can get either a compound or you can still remain as an element. Okay, you can still remain as an element. Now try to see it at a more deeper level. So elements means the elements in their pure form are always identified by their atoms, just like what we see in the periodic table. Okay, now these atoms are going to form bonds. Bond formation means, as we studied, it can be a chemical change. When a chemical change happens, new substances form. So bond formation will take place. So the atoms will bond, and the atoms will bond, and if the atoms bond, you are going to get molecules under any circumstances. Molecules, this side also you get molecules. Let's have the picture clear. So the molecules can be the molecules of compound, or the molecules can be molecules of element. Are we clear on this? If you still want some what do you call, no sir, I did not understand, so let's understand that one of the example would be that I have atoms of oxygen and oxygen bond together and form oxygen, is still an element but in molecular form. Atom of sodium reacts with an atom of chlorine and forms sodium chloride. Now what is happening? We are having two different atoms. First atoms forms molecules and then it's forming a compound out here. Is this clear? Or if you find that this is becoming too heavy, slowly as we go it will start getting clearer. So in chemical bonds, who are the participants in chemical bonds? Atoms. Atoms bond with, it can be same atoms, or they will bond with other atoms. If they bond with same atoms, then also they are, in both cases they are forming molecules. Sorry, I should not make it this way, I should write it this way so that your basic funda is clear. Then the book has written it in a very easy language. Here also you will get a molecule, here also you will get a molecule, but here the element structure remains. Here your structure will be that of a compound. Clear? Is this much clear? Right? So our chapter being of chemical bonds, we will be more interested to study what is this bond and what is happening. Can I remove this part? Is this part clear? ठीक है, क्या होता है? All the elements that you see on the periodic table are represented by their atoms. These atoms will bond, and then if they bond with the same family together, they form molecules and they will be in elemental state. If they bond with other atoms, then it will become compounds. In both the cases, after bonding, they become molecules. ठीक है, अब आगे देखते हैं. आ जाओ. Now we have roughly around say 114 elements with us, roughly, and 114 elements means at my level I'll say I have got 114 different type of atoms. The first question: do sir every atoms form bond with themselves? No, not exactly. From here we will subtract the inert atoms. Who are the inert atoms? Helium, neon, argon, krypton, xenon and radon. They never form bonds. That's why they are chemically inert. इनको subtract करके जो बाकी रहेंगे ना, the rest form bonds. क्या ये पिक्चर आपको क्लियर हुआ? Now the question arises, sir, what was special between them and them that they form bonds and they don't form bonds, right? The reason is these are said to be stable, chemically inert. In other language you say they are also noble. They don't react with anyone. They don't react with anyone. Please understand, they do not react. That means this particular statement that I have gone, I'm just trying to give you a blueprint of the chapter so that it becomes easy. This one is going to be a decisive factor. That means, do you want to say, sir, that if you react, you will form bonds? In a sense, yes. If you react, you will form bonds. Okay? If you react, you will form bonds. Then question comes, sir, why do you react? Why do atoms react? Same question. Answer would be to gain stability. Stability. So, do you mean to say, sir, the 114 minus 7 elements that we see on the periodic table, they are unstable? Yes, they are unstable. They are just like the beautiful faces on a matrimonial site. They look very beautiful. They are all good natured people, but when you actually see them, then they are all having different sort of tantrums within them. So the atoms do react because the atoms want to gain stability. The other atoms are not stable. So my first question is that, sir, what makes you confirm on this stability? I would say stability is defined by the inert gas electronic configuration. And what is the inert gas electronic configuration all about? If you are one shell, if you are a single shell, you should be a duplet, and if you are greater than one, then you should be an octet. कहानी क्लियर हो गया? इसी के ऊपर ही पूरा इनऑर्गेनिक केमिस्ट्री है. अब जरा माइंड मैप देखो. 114 elements means 114 types of atoms. All do not react. Only the ones apart from the inert gases, they react. Why do they react? Sir, why they do not form bonds, rather, because we are studying bonds. Bonds are formed by those who will react. Why do you react? You react because you want to get stability. In order to get stability means you are desperate to form the nearest inert gas configuration. And what is the inert gas configuration? If you are a single shell entity, you will like to be a duplet. Duplet means 2 electrons on the outermost orbital. This duplet and octet are all in terms of the valence electron. Children, if you don't understand anything, stop me then and there, but don't gulp. Okay, the valence electron should be in a duplet state or should be in an octet state. Itna clear hua? Are we fine? Now, as you read whenever you will be reading the book, you start seeing these notes. This will help you understand everything in the book. Is this clear? Right. Now, next part to it. So we have understood that an atom. So if you try to look at an atom's perspective, let's say we have a very deary atom. We have an atom. This is an atom. The atom would first check inert. The answer can be Y and N. If it is Y, stop. Flowchart. If it is no, then the question arises now. Then the question arises. We'll go there. If it is not, that means if it is not because it does not have its inert gas. Not means how did you get to know? No, I don't have the electronic configuration like that of a inert gas. That means my valence shell does not show either an octet or a duplet, right? Now, the 114 that you have elements, okay, these 114 are usually classified in 3 heads. One is known as metal, non-metal, and also we have got something which is known as metalloid. Okay, what are metals? Metals are the ones, if you see on periodic table, then group 1, group 2, then the entire D block, followed by, in our case, up to group 13. Okay, in your case, group 1, group 2, it will be said like 1, 2, 1, 2, then 2A, 2B, 2C. So it's 8 up till here, right? 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, and 3. In your language, as per Cambridge, it will be group 1, group 2, group 3. In our language, 1, 2, and up to 13. All these are metals. All these are said to be metals, usually. Okay, and on the left hand side we have, the left hand side has non-metals, and that 14 ke aspas like this we have got some metalloids. There are some very few metalloids out here. What are metalloids? Metalloids are those which have got their, what to say, properties in between metals and non-metals, like say carbon, silicon, germanium. These are all metalloids. इतना पढ़ना नहीं है, हमें सिर्फ metal non-metal जानना है, right? So we look at metals and non-metals. So roughly we will have, if you are not inert, then we try to check whether you are a metal or you are a non-metal. ठीक है? Let's say you are a metal. Try to grasp now. If you are a metal, you will always have the number of electrons on your valence shell will be less than 4 electrons. Valence electrons will be less than 4 electrons. Will be less than 4. Group 1, how many valence electron? 1. Group 2, 2. Is that getting clear now? Sodium has got 1 valence electron, 281. Magnesium 282. Aluminium 3, like that. So if you are actually a metal, you will have less than 4. That means how many number of electrons you can have, beta? 1, 2 and 3 at most. Got it? If you are a metalloid, you will generally have 4 electrons. Now that we will study later. But if you are a non-metal, that means you are either the gases or the liquids, you will have valence electron 5, 6 and 7. Why didn't I write 8? 8 होने से तो ऊपर ही चला जाएगा ना, ठीक है ना, समझ में आया? 5, 6 and 7, and another one is 1, 2 and 3. So here starts the imbalance of nature. Kirtan, able to follow now the storyline? Here starts the imbalance of nature, that as a metal you have got 1, 2, 3 at most electrons on your outermost orbit. What would be your lookout for? Unless and until you are on period 1. Period 1 has got hydrogen and helium. After that everybody is more than one shell. Your lookout is for 8. But God has blessed you with how much maximum? 3. So your want may be 7 for this fellow, 6 for this fellow and 5 for this fellow. Got it? And if you look at these fellows, then their want will be 3, 2 and 1. Is that understood? Right? This is the story of instability. You are unstable because you are falling short. Now we say that elements or atoms react, they form bonds, and after forming bonds, they attain stability. What is the story? The story is like this, that atoms will actually react. Another language of react is form bonds, whatever it is, and then they will be stable. That means after forming bonds, that is reacting, ये वाला हाल नहीं रहेगा, 8 तो हो जाएगा. Yeah beta, tell me. That we will see now. Right now, whether I am a metal or a non-metal, I don't have a octet. Sir, why are you not talking about duplet? Duplet बड़ा rare है, सिर्फ group 1 में ही duplet है, and maximum in period 2. We'll come to duplet also. ज़्यादा octet की बात करते हैं. We don't have an octet out here. That means atoms, when they react, they become stable, they form bonds, and reaction means bond formation or bond breaking, whatever it is. Once you form bonds, you become stable. That means, can I understand one thing? That after bond has been formed, you should be quiet. No more halla gulla now. Your stability has been addressed. That means 8 to ho gaya hoga. Got it? Is this thing getting clear? That means whenever bond is getting formed, one thing another we should understand, valence electron का ट्रांजैक्शन हो रहा है. कैसा ट्रांजैक्शन हो सकता है? लूज हो सकता है, गेन हो सकता है, एक और भी चीज होता है, शेयर भी हो सकता है. Is the storyline getting clear? Ashmita, are you getting clear now on this? That whenever they are forming bonds, as I told you, in a reaction, who takes part? The valence electron takes part. Reaction is like a war. The army and the BSF go. Our police station does not go in a war. So the valence electrons take part. The valence electrons will now form bond. In other ways, since we say that after bond formation, the address of octet is addressed or say duplet is addressed, that means valence electrons must be undergoing a transaction, the transaction can be either lose, gain or share. समझ में आया? और यहां से आइए लिखते हैं एक डेफिनेशन, और डेफिनेशन का टर्म रहेगा, द टर्म ऑफ दैट डेफिनेशन वुड बी वैलेंसी. वैलेंसी, राइट डाउन. वैलेंसी इज द टेंडेंसी ऑफ एन एटम. वैलेंसी इज द टेंडेंसी ऑफ एन एटम. अभी देखो, look at my hands. Tendency of an atom to lose, gain or share valence electrons in order to attain the electronic configuration of the nearest inert gas atom. Okay, let us understand. The question arises, see why you are giving the definition of valency. I showed you that the transaction can happen in three forms. Now your second question should be, sir, how do I know which form the transaction will take place? Then that will be addressed by a tendency. How do I know you are a destructive boy or no? No, whenever he comes, he breaks glasses. I have to understand your tendency. So every atom will have a tendency. The tendency might be to lose, gain or share. I am trying to understand that property. That property is known as valency. So write down, valency is the tendency of an atom to gain, lose or share valence electrons in order to attain the inert gas configuration of the nearest, or in order to obtain the electronic configuration of the nearest inert gas atom. In order to obtain the electronic configuration of the nearest inert gas atom. Have we understood? Correct? So we rub again all these things, right? पहले क्लियर हो जाएगा, फिर किताब पढ़ोगे सब क्लियर होगा. आ जाओ. So I'm going to write about now, I'm going to mention second period and third period. Okay, we're going to mention the second period and the third period, right? And group wise, group 1, group 2, I'm leaving these inert gases. This is 1, 2, 3, 4, 5, 6, 7. Okay, 3, 4, 5, 6, 7 I'm leaving. So these are known as a 2A, 2B, 2C, 2D in your book. So 1, 2, and in our sense we will go to 13, 14, 15, 16, 17, 18. यही पे खेल होता है, ठीक है? And as students of grade 9, you are supposed to bang your head only up till atomic number 20. ठीक है? So this is group 1, G1, G2. As per your book, this will be G3, but I am writing from my sense. This is G13, group 14, group 15, group 16, group 17, group 18. In Cambridge, they will write this as group 1, group 2, 3, 4, 5, 6, 7, and 8. 8 standing for inert. And here we have our D block, which is known as the inert gases. ठीक है? इनको हम 2A, 2B, 2C ऐसे करके देखते हैं. But in the IUPAC way, we call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it goes this way. So let's start filling it up. So we are at second period. So in second period means we will have sodium, we'll have magnesium. After that, we'll have aluminium. Then we will have silicon, followed by sulfur, phosphorus. Then sulfur, then fluorine, chlorine, and then neon, argon. This is krypton, okay, and two more out here, potassium and calcium. इतना ही हम देखते हैं. And if you see the top one, if you want to see first period also, we can see first period hydrogen followed by helium. ठीक है ना? Hydrogen, helium. Oh, sorry, this is fourth period. This is fourth. This is third. And let's take the second. Second period would be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Are we fine till so far? The period number tells you the shell count. First period means one shell. Second period elements will have 2 shells. Means duplet criteria is only for hydrogen and helium. Third period has got how many shells? 3 shells. Fourth period has got 4 shells. Clear? Chalo, अब देखते हैं. Now we said that the atoms have got tendencies like either to gain, lose or share. So I'm going to write down the valence electron count. Let's say this is group 1. So helium has got 1 valence electron, sodium has got 1, potassium has got 1 valence electron. Beryllium has got 2, magnesium 2, calcium 2, boron has got 3, aluminium has got 3, carbon has got 4, 4, 5, 5, 6, 6, 7, 7, and this one has got 2, 8 and 8. Clear? This is what everyone is trying to strive for. Everyone is trying to strive for this. So if you know the mathematics, it will become easy. Now, everyone has a rat race now to become the nearest one. So let's plot some nearest. For lithium, if you see lithium, it's in second period. So lithium will try to become neon. Sodium will try to become argon. And potassium will try to become krypton. That is the race for. So if you look at lithium, lithium's electronic configuration is 2, 1, whereas neon is what? 2, 8. What is the demand? The demand is for 7 more electrons. If you look at sodium, then sodium is 281 and it wants to become 28. 8. So the demand is for another 7, and similarly for potassium also the demand will be for 7. Now take some base rules. The maximum number of electrons that an atom can gain, max gain, will be equal to 3, not more than 3. 3 is the maximum that you can gain. Based on that arithmetic, now tell me, will lithium ever become neon? No, no chance. Sodium ever become argon? No chance. And will potassium ever become krypton? No chance. And if you look at these poor fellows, they are just 1 extra electron, valence electron, than the group 1 counterparts. Understood? And let's come up till here, aluminium. And I told you that up till this portion is what we consider as metals. These are all metals, okay? These are all metals. तो एक तो चीज देखने को ही मिल रहा है, metals cannot become have an electronic configuration of the inert gas of their row by gaining electrons. The maximum gain they want is 7, 6, 5. But what did we say? How much can you gain maximum? 3. तो भैया तुम तो ये बन ही नहीं सकते हो. Now they have to look for the alternate. If I cannot become the good child of my colony, let me become the good child of the previous colony. So let's look at lithium. The element inert gas just above neon is helium. Helium has got 2 valence electron and our fellow lithium has got 2 and 1. So what it does, it starts losing this electron. Now, does it match with helium? Yes, it matches. Same with sodium. If it loses 1 electron, it matches with neon. And same with potassium. Potassium will be 2881. Okay, 2881. So if it loses this 1 electron, potassium matches with argon. Is the story getting clear to you? I need stability. I will form bond. This your book is not saying. But what type of bond I will form? Sir, bond is always some sort of electron transaction. The type of bond I will try to form is a bond where I should be losing electrons. And if you take the story of beryllium, beryllium also wants to lose 2 electrons. Agreed? Magnesium also wants to lose 2 electrons. Calcium also wants to lose 2 electrons. Our friend boron wants to lose 3 electrons and aluminium wants to lose 3 electrons. So storyline is very clear that if you are a metal, you are going to lose n number of electrons. N depends upon which group you are in. If you are in group 1, you will lose 1 electron. If you are in group 2, you lose 2 electron. If you are in group 3, you lose 3 electron. Maybe if you, I know it's getting late, if you anytime feel sleepy, something to munch, I have absolutely no issues. Better cookies, something you keep munching so that you remain alive, awake rather, alive to you will be. Okay, so metals are going to lose n number of electrons, and in this case the metals become with the n plus. देखो तो बच्चा ये समझ में आ रहा है कि नहीं ये इक्वेशन. A metal loses n number of electrons and gets n number of positive charges. Just imagine, I am a neutral metal. I have got 7 protons, 7 electrons. You took away 2 electrons. So how many electrons I have? 5. How many protons I have? 7. So the net positive charge on my head is 2. 2. If you want to see it with example, sodium loses 1 electron, forms sodium and are we fine? ठीक है? ऐसे entity को, again I will be teaching more than book but will help in some other chapter, we call them as cation. Cation, how do you write it? Cation, so that you never make a mistake. Positive is always cation. Yes, तो आपका cation form हो गया. तो स्टोरी कहां पे है? स्टोरी वाज दैट आई एम एन एटम ऑफ एन एलिमेंट. I am not an inert gas. That means I am unstable. I will form bonds. That means I'll react with some other element or with me atoms of my own family members, and then I get stability. So when I get stability, bonds are formed, and in that case, what is happening? My valence electron transaction is happening. This transaction can be loose gain shared, and if I am a metal, I would like to lose. A metal never gains electron because the maximum gain, how much? Again, now ask yourself like a devil's advocate, sir, why does a metal not gain electron? Because an atom cannot gain more than 3 and it doesn't help me. My minimum count will be these brothers who need 5 and you're giving me only 3, so I will never gain. I don't want. ले जाओ. Metals are donors. तो ये जो एटम्स है ना, इनको हम बोलेंगे these are electropositive in nature. They are electropositive valencies. Their valencies are electropositive, means they form ions which will be positive in nature. Is that clear? Have you understood? Understood? So 3 type of transaction I told you: gain, lose, share. So we have ruled out gaining. Lose, we know that we want to lose. Let's talk about sharing. What is sharing? Let's define sharing from English literature. If I share a marker pen with Sahasra, that means I will bring 1 marker pen, she will also bring 1 marker pen, or I will pay for this and you will also pay for this. Again, listen to me. I will pay for this, you will also pay. I will contribute electron, you will also contribute electron. I don't want electron, because the want that I have you can't give me. I want 5 minimum for a child like aluminium. I want 6 minimum for a child like magnesium. I want 7 for sodium. तो आप क्या शेयर करोगे मेरे साथ? कितना लाओगे? See, as per the protocol, I am not supposed to spend more than 3 rupees. That doesn't help me. So I can't share with you. Is that understood? Sharing gets ruled out. समझ में आ रहा है? Sharing is also getting ruled out, but we will see later on whether sharing happens or not. We will see. Sharing gets ruled out as of now. Metals का कहानी clear हो गया. All the metals that we are going to have, these metals are going to always donate electrons. Now let us have a look at some of the non-metals. Okay, so let's take up non-metals from, say, we will not study this group right now. थोड़ा सा देर में पढ़ेंगे. Let us take all these 3. Let's take nitrogen. Nitrogen's atomic number is how much? 7. So what is the electronic configuration? 2 5. It wants to become 2 8. The demand is for 3. The demand is for 3. How much can a person maximum gain? 3. Matching? Matching. Nitrogen will be a very good acceptor. Can nitrogen share? Yes. If somebody is willing to share 3 electrons, nitrogen is very happy. तो इसके लिए sharing भी possible है, gaining भी possible है. और आगे देखते हैं ऑक्सीजन. It has got an electronic configuration of 2 6. It needs plus 2 to become 2 8. Happy? The law allows you to get 3. Isostar need only 2. And if you look at chlorine, वो तो और भी easy है. वो तो कहता है मेरे को सिर्फ बस एक चाहिए. I need only 1 to become 2 8. Have we understood? Can we gain? Yes, we'll happily gain. Can we share? Yes, we can share also if somebody comes with these, because our hunger is within the defined limit of transaction. So now tell me, how many atoms, how many electrons can an atom gain? 3 at most. How many can you lose? 3. 3 only. Because if you are gaining 3, somebody must be losing 3. If you are, acha, how can gain happen? Just let us look at this. How can you gain? How can you gain? Either somebody is losing or somebody is sharing with you. If you are gaining 3, then somebody is either sharing 3 or losing 3. Not plus 3, I'll just write 3. Right? Now, for sharing, there is a different law. Share. Max that an electron can be shared is 4. 4. Max that you can lose is 3. 3 gain, 3 loss, and 4 maximum can be shared. And 4 maximum can be shared. Is that clear? अब देखो चैप्टर कितना क्लियर हो जाएगा. अभी इसको देखते हैं. ये जो है ना, ये metalloid. These metalloids in Hindi we call them thali ka बैंगन. They have no stand on their own. They will go this side, they will go this side. Look at carbon. Carbon's atomic number is 6, which means its electronic configuration is 2 4. 4 is very dicey. Can you gain 4? Yes. If somebody is ready to share 4, I can gain 4. Can you lose 4? Yes, I can donate 4 also. मैं इधर भी जा सकता हूँ, मैं उधर भी जा सकता हूँ. And when you study organic chemistry, why is organic chemistry studied separately? Because of this property. A carbon can bond with a carbon. This carbon also needs 4, this also needs 4. It can bond with more carbon, and you can have enough number of chains. So many compounds. Right now, just look at your body, right from your watch, this, everything is carbon. Anything that is plastic is carbon. So, and right from the medicines to what you are eating, what you are wearing, what you are seeing, what you are holding, everything is carbon in your body. How does it form so many compounds? Unique property. This we call as catenation. We will learn this when we learn organic chemistry, because they have got 4 electrons. They can pair with themselves. मेरे को 4 चाहिए, उसको भी 4 चाहिए. आ जाओ एक साथ दोस्त बन जाए. समझ में आ रहा है? तो एक इक्वेशन इसका भी लिख लें. A non-metal can always gain n number of electrons and can become non-metal n minus. समझ में आया? And it can also share. I have not written it for share. I am just writing it for like it can lose electrons, it will gain electrons. Are we done? Based on this knowledge, we summarize it in this manner, and correct me bachcha log if you have not understood. Sir, the number of atoms are as the number of elements we know. Very good. Please subtract the inert gases. They are the good boys. Rest of them are not so good boys. So we have to make them the good boys of the town. These good boys are divided under 2 heads, metals and non-metals. The left side of the periodic table is all metals, the right side is all non-metals. And there is a partial section of metalloids also. The metals are the fellows who cannot become the good boys of their colony. Why? Because they cannot get more than 3 electrons. Their demand is minimum 5. So they try to lose electrons and have got a electropositive valency. And what should be the valency of non-metals? Electronegative. Non-metals always want to gain electrons. And their requirement is also very less. Their maximum requirement is 3, which your law permits, and rest of the members, they have got demand which is less than 3. The law permits it very nicely. Now one more question comes. Sir, a non-metal you said will always gain. Very good. So let's take one non-metal. This is a non-metal. It has not yet become an inert gas atom. It can gain. This is another non-metal, right? It has also not become an inert gas. It can also gain. What if both of them strike a deal between themselves? Why not we share electrons? That is like a gain to you also, and your electrons are a gain to me also. And in that case, if we are able to achieve An octet for both you and me. Deal done. You get it? Whereas if you bring two metals, and he says, I want to give, I will share with you, कितना share करोगे? तीन ही ना, कोई फायदा नहीं. Metals hate sharing. Metals are like electrons, we don't want you, and these are electrons, please come. Are you getting it? So here, another thing that you should understand is, between non-metals, sharing is also possible as long as the arithmetic matches. Means, I share 5 rupee with you, you share 3 rupee with me, but somehow after that sharing it has become, I got 8, you are also having 8. हो गया sharing के बाद. अगर ऐसा mathematics हो गया, which we will see now, then also they are happy. With this story we go ahead. Have you understood this or not? Yeah, beta बोलो. शेयर में हम इलेक्ट्रोपॉजिटिव नेगेटिव नहीं देखते हैं. इलेक्ट्रोपॉजिटिव बनने के लिए, वेरी नाइस क्वेश्चन, टू बिकम इलेक्ट्रोपॉजिटिव I should have a positive charge on me. When do I get a positive charge? When I lose the electron. I am sharing my money with you. I have not given you. Like you have right over the shared money, I have equal right over the shared money. Do you agree? There's a pack of sketch pen which both you and me are sharing. You can't call it yours. I can't call it mine. And I also can't say that I have lost the pack of sketch pen. You also can't say you've lost. Both of us have equal ownership on that. So where does the question arise of getting plus or minus? That's the beauty. Chemistry is the literature of science. The more you listen it like a story, the more clear it becomes. Have we understood this much? Now let's go and see what type of bonds and how do bonds form. This is where we'll go back to your book now. So far we have understood that if you are a metal, you are going to lose electron, and if you are a non-metal, then you are going to gain electron or you are going to share electrons. ठीक है? Now going one step further. हिब्रू लैटिन तो नहीं हो रहा है ना? एबल टू अंडरस्टैंड? क्या ढूंढ रहा है? पेन फेल, तीनों टैबलेट ढूंढ रहे हो. तो बुक के अंदर है, केमिस्ट्री बुक के अंदर. Or else if you want black or blue pen, I have. You want a black pen? It's there with me. Okay. So now going further with bonding, right? We now try to look at that after the chemical bonding happens, we get two type of compounds. When chemical bond happens, you are only going to study two type of chemical bonds. Generally there are three type of bonds, but at a basic level, one type of bonds we call are molecular compounds. And the other type is known as ionic compounds, also known as formula units. This name is generally less used in Cambridge. Formula units is also a name. Ionic compounds. इसका एक और नाम होता है covalent compounds. इसका एक और नाम होता है electrovalent compounds. Right? To form these type of compounds, the bond that we form are known as covalent bonds. So your chapter is all about these two type of bonds, and here we call them as ionic or electrovalent bond. Our study will be in such a manner that we will first concentrate on covalent bonds and then we will go to electrovalent bonds. So for today's class, electrovalent bond is ruled out. We're going to study covalent bonds. ठीक है? चलें आगे. And as of now, we just know nothing about covalent bonds, because the story that we concluded so far only tells me that metals are going to lose electrons, non-metals are going to share electrons or gain electrons, and then suddenly I came and told you that after bonding, two type of compounds are seen: molecular compounds, which are also known as covalent compounds, or electrovalent compounds. So we rub it again. Okay, just keep a note of it. We go back to our story. Okay. Before going to the compound, we first try to understand what is a covalent bond. Right? A covalent bond can be formed between an atom A and B, or it can be also formed with A with A. Try to understand. A covalent bond can be formed across A and B, or it can be formed between A and A. Means similar atoms or dissimilar atoms. In either case, they have to be from the non-metal family. Sir, ऐसा क्यों बोल रहे हो? Because a covalent bond is a bond formed by sharing of electrons. Is the story becoming clear now? It's by sharing of electrons. And who shares? You heard that? Who shares? Non-metals share. And don't forget those metalloids. They are super sharings because they have got 4 electrons they can share. So non-metals as well as metalloids, both are covered here. Non-metals as well as metalloids. Metalloids can also share because their demand is only 4, and while the law does not allow you to lose or gain 4, the law allows you to share 4. बच्चा समझ में आ रहा है तो? Sharing of 4 is allowed. If you understand this mathematics, everything becomes easy. So it can be formed between dissimilar and it can be formed between similar. But one thing we know, whether A and B bond together or A and A bond together, we are going to get a molecule. Are we fine? Because this is atomic level, this is the atoms. Atoms bond to give you molecule. In this case, क्या हो जाएगा बेटा? We are going to get a compound, and in this case, we still retain ourselves as an element. अब clear हो रहा है element compound? So let's take an example. Hydrogen plus hydrogen gives me hydrogen gas. Chlorine plus chlorine gives me chlorine gas. Oxygen plus oxygen gives me oxygen gas. These are all known as diatomic gases. Why diatomic? Every molecule of them contains 2 atoms. Let's take one more. Nitrogen plus nitrogen gives me what? Nitrogen gas. ये तो रिएक्शन है. अब हम इन्हें बॉन्डिंग के रूप में देखेंगे. ए बच्चा लोग, all you 3 ladies, is it becoming Greek and Latin? Oh yes, Ahiri is saying yes. Oh, it is Latin. I try to make it English, but you're not understanding. What do I do? I hope it is not that much Latin. And look at our Russian friend Needy. She's sitting all in Atlanta, trying to learn chemistry. Okay? Fine. इन एग्जाम्पल्स को देखते हैं पहले, तभी हमें और समझ में आएगा. Ready? Okay. Let's look at hydrogen. Now this is a reaction that we know. So what is a covalent bond? A covalent bond is a bond that is formed between atoms which can be similar or dissimilar, formed by sharing of electrons. But remember, after the bond has been formed, stability has been addressed, and the stability can be octet or duplet. एक बार bond form हो गया तो आपका energy should be up or down. Just think. Up nahi. Just think, you are a child, very, very naughty child. Then what do we say? She is very energetic. Whole house she has made on ruckus. But when you sleep at night, completely stable, all energy gone. कोई भी चीज का एनर्जी ज्यादा रहेगा तो वो अनस्टेबल है. Look at it. I try to balance this cap on this marker pen out here. ऐसा करके. It's unstable. Energy is very high. If I try to bring it at a bottom level, least energy. Less energy means more stable. So whenever bonds are formed, then always remember energy level has to get down. Energy level has to get down. In fact, we'll cover this in other chapter. You can just remember one thing. Mexo, bendo. Remember this. Did you understand? Mexo means what? Mexo's M stands for make. If you make bond, it is exothermic, energy out. Bendo means break, endo, energy in. Mexo, bendo. If you make bonds, then the process is exothermic, means energy. Exothermic you must have heard, right? Right? Exothermic. And bendo means if you break bonds, then it is endothermic. Okay? So energy out and bendo. Just for remembering, we'll capture this anyway in later chapters, not to worry about. So let's look at hydrogen. Hydrogen as an atom, this is one atom of hydrogen, and poor little atom has got 1 electron out here, right? This is another atom of hydrogen, and this atom has got one more electron out here. So what is bonding? Bonding is something in higher, if you try to go for higher classes, you will study bond होता क्या है, किसी ने bond देखा नहीं है, लेकिन these are all little bit of काल्पनिक. This nucleus will try to pull this nucleon because both of them are negative, they should detach from each other. This nucleus tries to pull this nucleus tries to pull this, pull करेगा थोड़ा सा, पुल करने के बाद कुछ ऐसा सिनारियो हो गया, ऐसा, and there is another one hydrogen, ऐसा, and the two electrons have come here. Understood? We call overlap of shells take place and the electron is shared. Now how many electrons does the left hand side hydrogen have? 2. How many does it have? 2. How many shells in hydrogen? 1. The address should be with duplet addressed. But in actual drawing we say the cross and dot structure. So actual drawing, how you should draw if they give you an exam, try to show the two electrons in a separate manner. We show this hydrogen with a dot and we show this hydrogen with a cross, and then we show the bonding hydrogen overlapping another hydrogen, and we show a dot and we show a cross, just to show that the cross came from this party and the dot came from this party. So henceforth all the drawings that I'm going to draw, I'm going to follow the electron dot structure. This is known as the cross and dot structure. Samjhi? Very good. Let's go more. Let's go to our darling friend nitrogen. No, first we go to chlorine. What is chlorine? Sir, chlorine is 287. Atomic number is 17, which means the electronic structure is 287. But sir, we are forming bonds. A bond is like a war. In war, who goes? Only the valence shell goes. Rest of the police station does not go. So let's make a chlorine atom. This is chlorine, and I have got 1, 2, 3, 4, 5, 6, 7. This is how we try to show 7. Got it? वहां से एक और क्लोरीन आया, उसके पास कैसा है 1, 2, 3, 4, 5, 6, 7. Agreed? And then what happens? Mergy. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine. 1, 2, 3, 3, 4, 5, 6, 7, 8. Chlorine molecule. Please understand, children, we are not forming any compounds as of now. We are only forming elements in their molecular form. Such elements, such compounds, just molecules will be known as diatomic gases. What is a diatomic gas? A diatomic gas is that gas whose every one particular molecule has got 2 atoms. एदू समझ में आ रहा है? मच्छर बाद में भगा इधर मंदे. डायटोमिक का मतलब समझ में आया? 2 atoms. ट्राइएटोमिक मतलब 3. ठीक है ना? मोनोएटोमिक कोई होता है क्या? मोनोएटोमिक होता है ना? हीलियम, नियॉन, आर्गन, क्रिप्टन, ज़ेनॉन, राडन, ऑल आर इनर्ट गैसेस. देखा, 1 मिनट मन हट जाने से आंसर नहीं हो पाता है. Whereas you know this thing. मन विचलित मत करो. मोनोएटोमिक, मुझे भी पाँव में दर्द होता है. देखो, मैंने सैंडल खोल लेता हूँ, ऐसे रखता हूँ, but you cannot take concentration out. मोनोएटोमिक आर इनर्ट गैसेस. डायटोमिक के सारे एग्जांपल्स दे रहा हूं अभी आपको. ठीक है, आगे बढ़ते हैं. आइए थोड़ा ऊपर को मिटाओ ये पोर्शन. ठीक है, वी आर ऑल स्टडीइंग कोवेलेंट बॉन्ड्स एंड आई एम ओनली डीलिंग दिस पार्ट ऑफ द स्टोरी. इसके बाद बच्चा go to school and get a murgi. You know what is a murgi? I told you, murgi is your best friend with whom you can share knowledge. Murgi learns and you reinforce your learning. Let's take the next one. Oxygen. Yes, Kirtan, tell me, what is the atomic number of oxygen? 8. What is the electronic configuration? 2, 6. 2, 6 means the outer orbit will look in what manner? The outer orbit will look like 1, 2, 3, 4, 5, 6. Fine? Good. And then we have got another oxygen, and that has got 1, 2, 3, 4, 5, 6, 7. 7. 7. Why 7? Just like this. 1, 2, 3, 4, 5, 6. Now let's see the bonding. Now when bonding happens, we'll have overlap. So how is the overlap? 1, 2, 1, 2. And this side are cross, circle, circle. That's it. Now count for the left hand side oxygen. Let's count for the left hand side oxygen. 2 circles, 4 circles, 2 more circles, 6 circles and 2 cross. आखिरी it is like ये जो shared है ना, ये मारा संपत्ति भी है, थारा भी है. So if you see here 1, 2, 3, 4, 5, 6, 7, 8. अश्विन का टेक्निक समझ में आया तो शेयरिंग है ना. You cannot say that वो आपका है, वो आपका भी है, मेरा भी है.
Yes.
Okay. So bonds are formed by sharing of atoms. And sharing कैसा हो रहा है? Equal contribution. If I bring in one, he or she also brings in one. But in the case of oxygen, we saw that I brought 2, he also brought 2. ठीक है? अब आइए नाइट्रोजन को देखते हैं. नाइट्रोजन. Nitrogen, what is the atomic number? 7. That means 2, 5. Right? 2, 5. So let's make for nitrogen. This is nitrogen. 1, 2, 1, 2, 3. Right? Then नाइट्रोजन का एटॉमिक नंबर कितना है? 7. सो आउटरमोस्ट इलेक्ट्रॉन्स आर 5. तो 5 हो गए, 5 बनाए हैं ऐसे. ठीक है. अनदर नाइट्रोजन ले लें यहां पे. 1, 2, सॉरी 1, 2, 3, 4, 5. Clear? And now our overlap has happened. Bond has formed. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8. Nitrogen, nitrogen. What did I tell you? As per rule, the maximum number that you can share is 4. But we are showing you sharing up to 3 out here. We can share one more also. But here we are sharing up to 3. Now look at the beauty. If you look at hydrogen and hydrogen, then only one. If you look at hydrogen and hydrogen, then it's one pair. In sharing, how many are there? One pair of electrons. A sharing with one pair. One pair means one has come from here, one has come from here. If you look at chlorine, chlorine, you see one pair. If you look at oxygen, oxygen, you see 2 pairs. And if you look at nitrogen, you see 3 pairs. Are we fine? Now in bonding language, we say when one pair of electron is shared, one pair is shared, then such a bond is known as single bond. Single bond, but a better word, single covalent bond. And I would show this as H-H. Single covalent bond. Chlorine, chlorine is a single covalent bond, Cl/3l. Oxygen, oxygen is a double bond, whereas nitrogen, nitrogen is a triple bond. The maximum number of bonds that can form between two similar or two atoms are how many? 2 similar, 3. 4 cannot be formed. 4 पे होगा नहीं. Allow करता है पर होएगा नहीं आपको. 8 बनेगा नहीं ना, ऐसा होगा नहीं. Carbon, carbon, see, you can also say, sir, with carbon and carbon, can I not make C2? Just try and think. Carbon has got 4 valence electron. Bring another carbon, C2. Maximum sharing that is allowed is 4 you can share, but maximum how much can you donate amongst all? 3. Sharing 4 allowed है, 3 से ज़्यादा नहीं जा सकता. तो C2 formation will never be seen. But between carbon and hydrogen, that will come later because we are still between the same molecule. We are still trying to see atom and atom. Okay, we are not studying this one, children. We are studying this one. Okay. But look at the chemical formula. Achha, you know the difference between symbol and formula? Symbol is to represent an atom. Formula will be always having a numeric number attached to it. It represents a molecule. Chemical formula likh lo. Chemical formula represents molecule. Chemical symbol will represent atom. Cu. What is Cu? Cu is a symbol. CuSO4 is a formula. A formula is like a recipe. एक copper, एक sulfur, 4 oxygen. CuSO4. Yeah. So you write chemical formula represents molecule. Chemical symbol represents atoms. क्या, और केमिकल फॉर्मूला में एक और चीज लिख लो बेटा, इट विल बी अल्फाबेट प्लस न्यूमेरिक, अल्फा न्यूमेरिक होता है वो, whereas symbol is always alpha, it cannot be numeric. अभी देखो, इधर आ जाओ, what is this? Hydrogen. What is this? Chlorine. What is this? Nitrogen. Now look at their formulas, O2, H2, Cl2, that means they are all diatomic. Diatomics are very classic example of covalent bonding. कोवलेंट बॉन्ड से मॉलिक्यूल भी बन सकता है, मॉलिक्यूल ही तो बनेगा, कंपाउंड भी बन सकता है, एलिमेंट। अभी हम सिर्फ एलिमेंट्स के एग्जांपल देख रहे हैं। अच्छा, सल्फर, यू नो सल्फर फॉर्म्स 8, ऑक्टा एटॉमिक है वो, S8 बन जाता है। सल्फर का 8 एटम्स ऑफ सल्फर ग्रुप टुगेदर, कॉम्प्लेक्स स्ट्रक्चर्स है, S8। क्लियर? Diatomic you understood? Did you understand what is single covalent bond? A single covalent bond is a type of bond between two atoms where one pair of electron is shared overall. Sir, is it that in single covalent bond the two participating atoms must be same? Oh no, not like that. Not like that at all. Although not, we will touch this, but since I have talked about it, sir, can you give one example? Why not? Take an atom of hydrogen, it has got one electron, and bring an atom of chlorine. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 6. How many pair of electrons shared? One pair. How will I write this compound as? HCl. HCl, hydrogen chloride. Yeah, please. Hydrogen chloride. I would suggest Thursday, na, why are you coming? You attend from home if it is easy for you. Because unnecessarily you lose walking time also, dear. And you will be fresh. Now you will go, you will get tired. So this is hydrogen chloride. And hydrogen chloride is actually a covalent compound. We have not yet studied compound. But I am trying to say, what is a single covalent bond? A single covalent bond is that type of covalent bond which is formed by sharing one pair of electrons. Either between same elements, then I get a covalent molecule of an element, or different elements, then I get a covalent molecule of a compound, HCl. Our next examples will be, we are going to see a lot of these things. Please understand, single bonds can form for diatomics, single bonds can form for compounds. Similarly, double bonds can also form for compounds. Triple bonds can also form for compounds. हमारे अगले क्लास में हम इसी चीज को देखेंगे, बट बिफोर या बोलो बेटा।
Sir, like I understood for one pair, like when they share, I didn't understand like how to determine like how 2 or 3 atoms pair.
2 और 3 एटम्स पे 2 नहीं बेटा, बॉन्डिंग जब होगा ना। अच्छा, वेरी वेरी गुड, वेरी गुड। आप so I'll ask you 3 questions. I hope you will only give the answer. Why do you form a bond?
Against stability.
What do you mean by stability?
Stability.
क्या स्टेबिलिटी क्या है? हंसते रहना मतलब मैथमेटिकली बताओ ना बेटा, व्हाट इज स्टेबिलिटी? हाउ डू यू डिफाइन स्टेबिलिटी? क्या कर देने से आप स्टेबल बन जाओगे? Yes, to completing the octet or duplet. Even one step before that, sir, I want to become the good boy of my colony or the nearest good boy to my colony.
Yes.
So what is that special in that good boy? Sir, that good boy has got an octet. I don't have an octet.
Okay.
So I want to form the octet. What are the options available with me? Gain, lose, share. That's why we say valency. Gain, lose, share. Then I will look at my nature. My nature is always loser. Right now we are seeing all these examples by non-metals. So we are taking those whose nature is a gainer. A gainer can also be a sharer. This one also wants to gain, this one also wants to gain. Share कर लो फिर। फिर आप हिसाब मिलाओ कि आपको कितना चाहिए। If I am a hydrogen, मेरे को एक ही और चाहिए बेटा, एक और। I just need one electron. Now see, hydrogen bonds because this hydrogen needs one electron. Then it will become what? Helium. बन गया helium 2. Left hand side hydrogen has got 2. Do you agree?
Yes.
राइट हैंड साइड हाइड्रोजन को भी 2 मिल गया. नाउ आई एम आस्किंग योर क्वेश्चन, सर आपको कैसे पता ऐसा होता है? चलो हाइड्रोजन की शादी क्लोरीन से कराते हैं. हाइड्रोजन को एक और चाहिए, क्लोरीन बोला ले लो, मेरा ये ले लो, ले लिया, हाइड्रोजन हीलियम बन गया. अग्रीड. एंड लुक एट क्लोरीन, क्लोरीन को 8 चाहिए, वो हाइड्रोजन का ले लिया, वो नियॉन बन गया. तुम भी खुश, मैं भी खुश. नाउ माय क्वेश्चन इज, विल यू शेयर मोर देन दिस? नहीं चाहिए बाबा, घर के खर्चे पूरे हो गए, काय को और शेयरिंग कर रहे हो? But when I come to oxygen, Ashmita, see, when I come to oxygen, I have got 6 electrons. So we shared the first pair of electron. Now you have 7, I have 7. Did you become the good boy of your colony? That is argon, no. Did I become the good boy? No. So what we did, we actually shared one more pair. Now you have 8, I have 8.
Okay.
And this is where Nidhi will get angry on me, because you are itching me to share one small thing of 15 seconds. Nidhi, 15 seconds, bear with me. Okay, though we'll study it in the next class, just 15 seconds. Have you heard about a compound when carbon burns in oxygen forms what? Carbon dioxide.
Yes.
चल ये करने के बाद आज की छुट्टी. कार्बन, how many electrons? 6. No, carbon's atomic number is 6. Carbon's atomic number is 6, so its electronic configuration is 2 4. 4 electrons out here, so let's make the 4 electrons of carbon. 1 2 3 4. Agreed? Fine. Ink is also finished, which is actually telling me that please have mercy on Nidhi. We will have mercy on Nidhi, don't worry. So we bond it with oxygen. How many outermost electrons for oxygen? 6. 6. 1 2 3 4 5 6. Agreed? And look at this oxygen now. Just count how many electrons for this oxygen. 2 2 4. Happy. Oxygen is happy. Carbon 2 4 6. I'm not happy. ले आओ एक और ऑक्सीजन यहाँ पे ससुरा. 1 2 3 4 5 6. 1 2 3 4 5 6 7 8 8. Carbon 1 2 3 4 5 6 7 8 8. Carbon has got a smiley face. Oxygen has a smiley face. Oxygen has a smiley face. Carbon, 2 pairs are shared, double bond O. 2 pairs are shared, double bond O. This is what you know as CO2. अब इससे ज्यादा क्यों चाहिए आपको भाई? घर के खारे खर्चे पूरे हो गए हमारे.
Yes, sir, I understood. Thank you, sir.
आज का रंगारंग कार्यक्रम यही समाप्त होता है. यार अभी ना खुजली आ गया, अभी और पढ़ाने को दिल करता है. But that बच्चा सी, why is she in America? Can't help it. Okay, चलो, I'm closing the